The title of my lecture is Space-Time Quaternions. In this lecture, I'll tell you about different type of quaternions, which allows you to take into account the properties of physical quantities in relation to the operation of spatial and temporal inversion. The plan of my lecture consists of 4 points. First, I would like to recall you shortly about Macfarlane quaternions and to discuss the spatial and space-time inversion operations. And at last, I'll tell you about space-time quaternions. Macfarlane quaternion consists of 2 parts, scalar part and vector part. The basis element A1, A2, and A3 has the specific multiplication and commutation rules. The squares of A elements are equal to 1. If we multiply A1 on A2, we obtain not A3 as in the Hamilton quaternion algebra, but A3 multiplied on value I, where I is the imaginary unit. The rules of multiplications and commutations can be represented as the following table. If we multiply A1 on A1, we obtain 1. If we multiply A1 on A2, we obtain A3. If we multiply A1 on A3, we obtain minus A2, and so on. The advantage of Macfarlane quaternions algebra is that the squares of vector in this algebra is positively defined. And of course, in this algebra, there is so-called Clifford product of vectors. The Clifford product is equal to sum of scalar and vector products. This allows us to write the different physical equations in very compact form. Some words about quaternion rotation. Quaternion can be rotated using the so-called operators of rotation. Here, theta is the angle of rotation, and vector n is the unit vector which is parallel to the axis of rotation. Since quaternion consists of scalar part and vector part, scalar part is not transformed under the rotation, and the transformation of quaternion is reduced to the transformation of vector part only. If we multiply our vector on operator of rotations, we obtain transformed vector, which is the expression for this vector is written here. In this expression, we assume the Clifford product of vectors. If we rewrite this equation in usual scalar and vector products, we obtain the following formula, which is very well known in vector algebra. So, space-time quaternions. Space-time quaternions consist of 4 components. Consist of scalar part and so-called space-time part. The basis ET, ER, and ETR have the same rules of multiplication and commutation as the basis element of Macfarlane quaternions. But these elements have the absolutely different properties. ET is so-called time unit, which is changed under time inversion. ER is the so-called space unit, which is changed under the space inversion. And ETR is space-time unit, which is changed under space and under time inversion. Let us consider space-time inversion in more detail. The space inversion is carried out using ET basis elements. If we multiply our quaternion on ET elements, we obtain new quaternion in which we obtain minus signs in space and space-time paths. The same practically if we the operation of time inversion is carried out using ER elements. In this case, we have the new quaternion with minus signs in time path and space-time path, and so on. The basis of space-time elements allows us to construct the 16 component values, so-called space-time schedules. Space-time schedules consist of 4 scalar paths, A, B, C, and D, and 4 vector paths, A, B, C, D. If we rewrite this formula in the following way, we can see that schedule consists of usual Macfarlane quaternion, time Macfarlane quaternion, space Macfarlane quaternions, and space-time Macfarlane quaternions. More detail about space-time schedules you can see in our paper, which is published in Advances in Applied Clifford Algebras. So, conclusion. The space-time basis allows taking into account the properties of physical quantities in relation to the operations of spatial and temporal inversions. This is the basis for the development of space-time algebra. In conclusion, I would like to recommend you our book, Space-Time Schedules and Their Applications in Relativistic Quantum Mechanics and Field Theory. This book is available through the internet. Here you can see the link to this book. And if you have any questions, or maybe you would like to discuss something, you can write me using this email, please. Thank you very much for your attention.